So doing that question again, but using an alternative geometric method, is I'm thinking here that this point here at 0, 4, the first coordinate of the triangle there, if I want to find out what the next coordinate is, then I just want to rotate it about 120 degrees. I'll then rotate it about 120 degrees again, and then 120 degrees back again to get back to the start. And so I've been doing that in the first year. What I'm going to do here is I'm going to start with putting in the matrix for the initial point. So that's 0, 4. And just push enter for that. And now I'm already changed this into degrees mode. You could do it in radians as well then. I know the rotation formula because it's cos 120, sine 120, and up here minus sine 120, cos 120. And I need to times that by matrix answer. So I'm doing that so I haven't got to repeat doing it again. That's just now going to put the 0, 4 into it. And so it's immediately going to tell me that my next point is minus 2 root 3 take away 2i. And if I push equals again, it gives me the one after. 2 root 3 minus 2i again. And to check I've got it right, 3 times round, there's the 0, 4 there. So if I wanted to do part B now then, part B says I've got a square with one point at 5, 0. So it's starting here at 5, 0. And because it's a square, we're going to do this 4 times. So square, first point was 5, 0. Put that in there. And the rotation for a square now is going to be cos 90, sine 90, minus sine 90, and cos 90, timesing that by matrix answer again. And so we started at 5, 0. The next point we're going to need is 0, 5. The one after is minus 5, 0. And the fourth point, 0, minus 5. Check all the way around, back to the beginning again. And of course, if you really wanted to, you could plot them all on the points here, and we'd have a square like that, not a diamond. That's a square there. For part C, because it's a pentagon, so 360 divided by 5 is 72 degrees for each one as it goes round, and a hexagon, 360 divided by 6 equals 60 degrees for each of them. I just think that's easier than the alternative versions, but it's nice to see there's lots of different ways of doing that. If I was doing the pentagon one here, then I'd be taking that first point there, I'd be changing it into its r theta form, and then sort of taking that and I'd be timesing it by 2 pi over 6 times by n and flipping it all the way around as it went, rotating it round.